Okay, I love these circle problems. So we need to find A through E. I don't really care what those say. Like, I could just like hide those literally for now. I don't care. I'm going to try to find everything that I possibly can. As I'm just visually looking at the circle, there's no central angle. There's no coming out of this center. Now, you could draw some central angles if you want. If you feel like something's going to help angle, by all means you can draw. I'm not going to encourage it for a little while till you get good at these problems. But what I first need to do is I need to read the problem. Okay, I have in circle O, that's just naming the center. I have chords. Just have a bunch of BC, AC. Chords stay within the circle. They go side to side. I have tangent PC. Sorry, there's no like good highlighting tool in this program. Tangent PC. Skim in the circle. Touching it once. Touching it once. Secant goes through and it touches it twice. It's really an extension of a... Okay, so PBA are drawn. Angle DBC is 40. DBC. This guy's 40 right here. It's 110. I do not think this diagram is very drawn to scale, but we're going to go with it anyway. The measure of arc AD to the measure of arc CB are in a ratio of 9 to 5. I know when I have a ratio, these are talking about parts. And I know, 9 plus 5 gives me 14 total parts. Okay? That. I'm going to go old school here. I know if this is 110, I know that the vertical angle is 110. I also know the linear pairs to this are using a single circle property right now. I also know that now I have a triangle here. So if this is 110, there's 180 degrees in a triangle, so I know that this has to be 7 triangle, which I don't think it's very isosceles, so that's why I'm saying that I don't think that this is really drawn to scale. Okay? Now, I'm going to look for inscribed angles. That's going to be my number 1. I'm looking for inscribed angles. Angles whose vertex is on the edge. A, I don't know this value here. I go along the circle. B, this is an inscribed angle right here. So to this arc right here. Angle is coming from, and that's where you're highlighting. And you're doing this right now because this pen is hard to move. So if this is 40, I double it in this angle. Okay? I do not have any diameters, so I don't have any semicircles, so I'm just going to keep working with what I have. I have another inscribed angle right here to this arc here. So 70 opens up to this arc right here. Now, I don't really know anything else, and I have to probably find all the arcs. If you can find all the arcs, you're going to be successful. So I'm going to deal with this. All right. I know that 140 and 180, I know that there's 360 degrees in a circle right now. Not right now, like forever. There's always 360. I don't know why I said right. I have 140 left. So this arc plus this arc have to sum to give me 140. So here's where these ratios come in. This AD is 9 parts. B is 5 parts out of 14 total. 140. 5/14ths of 140. It's not always going to be 140. It could be a semicircle. Could be in a triangle even. So if calculate 9/14ths of 140 is, then I'm going to be able to find what those arcs are. So 19 is going to be 90. All right. And then 10 times 5, this should be 50. And it gives 140 in your calculator if you don't believe me, but that's 50. Now what that does is it gives me more arcs, and I can find angles that these back up to. So if I look at the 50. The 50 right here backs up to this angle right here. So this angle has to be 20. Okay? I see a lot of triangles going on right here. So there's 180 degrees of triangle. This, or I can take the 90, back it up. This would be 45. Inscribed angles are always half. All right? Now let's keep going with background knowledge that we know. I know that here, all of those angles have to add to 180. Those are angles on a line. So if I subtract 45 and 40 from 180, the same. All right, I'm just using some circle stuff. All I've actually used so far is inscribed angles. That's been my go-to. All right. I just want to go see what we found so far. We found arc AB. We found arc AD. We found that to be 90. CP. We have not found BCP yet. It's this guy right here. ACP. We haven't found ACP yet either. So we've got to keep digging here on how to find these values. And again, I wish I could give them. I see this guy here. That's a chord. And this, I'm going to take half of this arc right here. A tangent and a chord is half of that arc. Now, 25 in the angle P. So 180 minus 25 minus 95 is going to, look at this big triangle right here. Look at that big one. You got one here, you got one here, you got a lot of triangles in here. So we found angle P. P. ACP is this whole thing here. Well, I know part of it's 70, I know part of it's 25. Now, even if I didn't know that, even if I did not know that, I could go, this is a chord, okay, this here is a tangent. So I know that if I want to find all of that angle here, if I didn't see triangles, I would have to take half of this, take half of 190, that gets 5. It's going to take practice, it's going to take highlighters, every problem is a little bit different, but they're just pieces of the puzzle. And really the only thing I used was the only pieces that I really needed to use. So try those pink problems, have fun with it.